In this video we're going to be discussing the concept of a parabola. We've already been through an ellipse, we got a circle, a hyperbola, and this is considered one of the, or the last of the four classic conic sections. There's a couple other ones if you delve deep into it, I suppose, but the more interesting ones here are going to be these four, and this is the last of those four. So a parabola, I've got some equations written on the left here, but let's talk about the graph right in the middle of the screen. And a parabola is going to have a vertex. Not really a center, not two vertices or four. It's kind of the same thing. If you want to think about the vertex of a parabola kind of being like the center of a hyperbola or an ellipse or even a circle, that's probably fine. As a matter of fact, if we take a look at the equations on the left, we've got h and k, and that's the center for the other three, but it's going to be this vertex right here. So as a matter of fact, maybe I should write that somewhere. Let's write that off on the right hand side. HK will be this center part right there. There's a couple other things though. It will have a focus, so we can write that down. In this case, this parabola has a focus right here. And there's also another part of a parabola that's like the focus. It's not really part of the parabola, but it is a very important line, and that is called the directrix. So we've got this guy as being the directrix right here. If you wanted to, you could also draw another line, and that other line would run right through the middle of everything. And that line is the axis of symmetry. Now you'll notice that the distance between the directrix and the vertex in this case, and the distance between the vertex and the focus is actually the same thing. And that same value here is going to be a variable we're going to call p. There is a funny thing that happens, and this is just something that you can use to help you graph. And there's a funny thing that happens right through the focus. So if you go parallel to the directrix through the focus, you get this line, and this line, I might misspell this, latus rectum is the name of that line right here. And it turns out that the distance here is p, this distance is p, and this distance away from the focus is just 2p. In other words, it looks like in this example we have 1, 2, 3, 4 grid lines between the directrix and the focus, and there's 1, 2, 3, 4 if we follow this out to the parabola. So that can kind of help you to graph these things. There's not too much else with these. If we take a look at the equations, you can see that if we open left and right, the y variable is the one that's going to be squared, and the x is what's not going to be squared. Also, there's going to be a value in front of this x term here, or at least the x minus h, and that's going to be 4p. So whatever value is here, we're going to want to divide by 4, and that'll give us this value of p. Up and down, we've got x minus h quantity squared is equal to 4p times y minus k. 4p is the same, the x minus h, the y minus k are just in different spots. For a parabola to occur, we're only going to have one of the variables being squared, and then the other one is not. If both of the variables are being squared, we've got one of the other three classic types of conic sections. One other thing that I'll mention here is that if you take any line and you draw that line, let's say from the directrix, so like a perpendicular line, and you draw that until it hits the curve, the distance between the directrix, the point on the parabola, and the focus is going to be the same. I don't know if you can see that. Hopefully you can. But this distance here is the same. And we could even do the same thing here. You know, we could bring this line all the way up until it hits the curve, and then bring that back to the focus, and that distance here will always be the same. One of the reasons why we can use the latus rectum to help us graph is because this distance here between the directrix and a point on the parabola and the focus is actually the same, and it's just 2p. So if we go up 4 units here, we're going to go over 4 units, or down I should say, right 4 and then down 4, and that distance will remain the same, and that's just kind of an understanding of what a parabola is.